Welcome to another fun-filled edition of Comet Algebra. This video is for Algebra 2, Chapter 6, Section 3, Zeros and Inequalities. So kind of two parts to this section. First, define the term zero. When we talk about a zero of a equation, or in this case a quadratic, a zero, another word for that is a root, a solution. When you're looking for the two answers, all of these terms mean zero. And we find these where it crosses the x-axis. And that is, of course, where y is 0. A function's real number zeros are the x-coordinates of its graph, the x-coordinates of the x-intercepts. In other words, where the graph crosses the x-axis. So I think I said x in that sentence 16 times. Question: do you remember how to find the y-intercepts? Hopefully you told me that to find the y-intercepts, you set x equal to 0. No matter how many x's there are, you put zeros in for all of them, and then you solve for the y. I'm going to keep repeating that so we don't forget it. We also need to know what a double root is. A double root is when you have a quadratic and you solve it and you get two answers twice. Or I should say the same answer twice. And we'll look at what the graph looks like of that in a minute. The graph is bouncing off the x-axis when we hit a double root. So we've already seen examples when this happens, and we'll look at what the graph looks like in just a moment. In example 1, we are asked to find the zeros and the y-intercept of each of these parabolas. No particular reason. I guess I'm just going to find the y-intercept first for letter A. So to find the y-intercept, remember, we put in 0 for each x. So y would equal 0 squared is 0 times 1/2 is 0 plus 0 plus 2. So therefore the y-intercept is 0, 2. And you do need to give it as a location on the graph. Now we're going to find the zeros. So we need to solve this quadratic. I guess I am partial to factoring. So I'm noticing I'm going to get rid of this 1/2. I'm going to take this whole equation and multiply it by 2. And of course, the intercepts are where y is equal to 0. So I'm going to put a 0 in for the y, and then I'm going to multiply these by 2. I think that's going to make this an easier problem to deal with. Now this looks a lot easier to factor. So now this factors into x plus 2 equals 0. So this first factor gives me a root of -2, and this factor also gives me a root of -2. So what this is called is a double root. And like I said, we're going to look at a graph of this in just a moment. Now let's solve letter B. Again, I'm going to find the y-intercept first by putting 0 in for the x. So I have -2. 0 take away 1 is -1, and we'll be squaring that and then adding 8. So -1 squared is +1. +1 times -2 is -2, plus 8 is 6. Therefore, the y-intercept is 0, 6. Now we need to solve this for the zeros, or the x-intercepts. So we're going to put this, the y then is equal to 0, because that's where the x-intercepts live. And this looks like it's set up nicely for the square root method. And in that method, I need to isolate the x squared term. So I'm going to get rid of this 8 and get rid of this -2 for my first steps. So if we subtracted an 8 from both sides and then divided by a -2, we would get a 4. And now I'm ready to take the square root of both sides, which leaves x minus 1 equal to plus minus 2. We always like it when we have a perfect square over here. So then my x is equal to 1 plus and minus 2, so we need to do the plus minus. So x is 3 and x is negative 1. So I have found the two zeros and the y-intercept. Now let's look at the possibilities when you graph a parabola. What we just had in our first example up there, and the a part, was a double root. And when you have a double root, in other words, you get the same answer twice, that means that the vertex is resting right on the x-axis. And right here at 3, that is the double root. Later on when we're graphing things that are going up and down and many more answers to find, I call this bounces off of. A double root bounces off of the x-axis. So when you see this, what I want you to recognize is right there at that point, there are two answers. And that'll become very important later. Another possibility when you graph a parabola, let's just say it's an upside down one, and it crosses the x-axis twice. These would be real numbers. Now sometimes these numbers are perfect squares, in which case they're rational, and sometimes they're not perfect squares, and there's a square root symbol in them, and they could be irrational. But either way, they are real, they exist. There's two answers where the two intercepts are. And another possibility, remember when we got two complex roots when there was an I or an imaginary number in your answer? That means your answers are imaginary. They don't really exist. They don't cross. This doesn't cross the x-axis. So maybe the parabola looks something like this. No real answers because it's not crossing the x. Or maybe it's upside down and going down. So when this happens, we know we have i's in the answer. They are imaginary. So those are the three possibilities that could happen when we're solving quadratics. So looking at the graph of the parabola can give you some valuable information. If you see it bouncing off the x, you know you're going to find two answers that are exactly the same. If it crosses twice, you know you have some real answers to look for. Maybe perfect squares, maybe not. But if you graph it and you see you have the parabola never crossing the x, you know right away you're going to have i's in your answers. And that can be very useful to know. In example 2, we're asked to find the zeros of each function. In other words, where do they cross the x-axis? And that is where y is 0. So I'm just going to start by writing 0 equals the rest of this quadratic. If you're interested, you can graph this on your calculator, and if you would do that, you would see that we end up with a parabola, something like this. It crosses the x twice. So even before I start the problem, I know that I'm looking for two real answers. This seems to be very nicely set up for the square root method. So I'm going to subtract a 6 from both sides, and haven't isolated this squared term yet. So now I'm going to multiply both sides by a -1. So these are both positive. And now I'm going to square root both sides. I'm just going to flip this around because I'm more accustomed to seeing it like this. And now we just, sorry, I forgot the square root sign there. There we go. So now I'm going to bring that 2 over, and so our answers are -2 plus minus square root 6. And that's usually how we've been writing them. This time, it's asking us to take our irrational roots and do them to the nearest hundredth. So this becomes calculator work. When I punch on my calculator, -2 plus square root 6 to the nearest hundredth, I get 0.45. When I type in -2 minus square root 6, I get -4.45. So these are the two zeros rounded to the nearest hundredth place. All right, part B now. Again, I find it helpful to look at the graph so I kind of know what I'm dealing with. So when I put this into my calculator, the graph looks something like this. And I think this is valuable information. I know right now that I'm going to be finding two imaginary answers. There's going to be i's in the answers, and that tells me right away this thing does not factor, so your choices are to complete the square or use quadratic formula, whatever you prefer. This time I chose quadratic formula, but either way we should get the same answer, so you use your preferred method. So let's see, 4 minus 12, this is going to give me a negative 8 under the radical. And we'll simplify this if possible. 8 has a 4 in it, and of course the negative sign has to come out as an I. So then I have 2 plus or minus 2I square root 2 all over 2. Remember, this is all or nothing for reducing. And since every one of these terms has a 2 in it, I can divide it out. 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. So the final answer is 1 plus minus I square root 2. Now this one is imaginary. This isn't an irrational number, so I cannot approximate this to the nearest hundredth. So that's it. That's all I can do. And that fit in with what I saw at the graph, not crossing the x. We knew we were going to have two imaginaries. The last two things we're going to look at are calculator skills. When we use greater and less than in quadratics, either it's going to shade inside the parabola or outside the parabola. And if you remember right, the n equals is an app on your calculator. So push the app button, and in that menu that comes up, look for n equals and turn that app on. So of course, if it's not solved for y, you would solve for y, and then you just put this into the calculator, and let's take a look at the display. So if you take a look at the graph on your calc screen, and I want you to transfer graphs accurately, and in order to do so, we need to know what's called the critical points. One of the critical points in a parabola is the vertex. So you can use the methods we learned the other day to calculate that the vertex is at 2, 1, so we put a point there. I put in zeros for x, and I found that the y-intercept is down here at -3, so that's a critical point. And we noticed that this is not being made wider or narrower, so this is the same shape as the parent equation. So you go over 1 and 1, and put a point, 1 and 1, and put a point. And then we can see that this is a less than sign, so it doesn't include the line that makes the parabola, so we need to make it out of a dotted line on both sides. And then since its y is less than, then the shading would be inside the parabola. So we put all the shading in here. All the solutions lie inside this parabola. But please note, if you're going to graph this on your homework or on a test, I'm going to check if you have it graphed accurately. The vertex needs to be where it needs to be. You need to cross the x where it's supposed to cross the x, and cross the y where it's supposed to be the intercepts. You have to be accurate. All right, this last example is probably the easiest one. We're just going to review how to find zeros by using your calculator. So of course, solve this for y or equal to 0, however you see that. So we need to bring the 3 over. And now type this into your calc, your y equals key, and then hit graph. And to find the command that gives us the zeros, it's under the calc menu, which is found second trace is the calc menu. And under that menu, could you please choose the option that says 0? Then remember you have to do the left bound and right bound. So if I'm after this particular 0 right here, we need the blinking cursor first above it for the left boundary, then move the cursor over. After you hit enter, move the cursor over and hit enter for the right boundary. Hit enter one more time, and the display at the bottom should say x equals negative 1.693 while y is 0. So that's the first 0, which your calculator gave you. And then do the same thing for the other 0 over here. So you'll do the left boundary where the cursor is here, hit enter, move the cursor up and do the right boundary, hit enter and enter again, and then the display at the bottom this time should say point, kind of a long decimal, 443 when y is 0. So that's the other 0 of this function to the nearest hundredth is 0.44. So again, that's pretty easy. We can find the zeros on our calculator. All right, now you should have the knowledge you need to do section 6.3, so have fun with math.